Hello, Spark fans, and welcome back to Advancing Spark. So, we've had a few suggestions saying that you'd really like it if we stepped into the Spark UI. So, this time we're going to do a bit of a what's happening in there, what's going on in my cluster, how do I use the Spark UI to try and do some troubleshooting. And we talked about one or two of these things before, so I'll do a quick recap of what's going on inside Spark, and then how you use the Spark UI to diagnose it, to figure out what's going on, to use it in the middle of your queries. So don't forget to like and subscribe. Let me know if you've got any questions down in the comments, and otherwise, let's have a bit of a look. So starting off with a bit of a refresh. How does actually Spark work under the hood? So we've got this thing, we've got a driver and we've got some workers. Depending on how you've set your cluster up, you'll have a variable number of workers that are different sizes. Now, the way Spark currently works is that these are all based in JVMs. Now, we know Databricks is working on this Photon engine, which is all C++ based, and it's all a whole different thing. Currently, the way Spark works everywhere, for Photons rolled out, is this JVM. So we've got a Java virtual machine, which in Databricks is one-to-one with each of our workers. Now, inside each JVM, we have an executor. This is just the Spark program running in there. And then inside that, we have a number of slots. A slot is an available bit of compute. It's a CPU. So if I've got like this, I've got 4 executors that have got 4 CPUs each. I've got 16 slots available for me to do work on. So the size of your worker, how big each worker is, therefore how many CPUs it has, changes the number of slots, and the number of workers changes the number of slots. And that makes sense. Each slot can process 1 unit of work at a time before we get to the Photon stuff. So that's how our cluster works. When we're doing a job, dataframe.read, all that kind of stuff, that has transformations in there, which can be narrow or wide. And the type of transformation that we're doing will denote whether we need a shuffle. Again, so a wide transformation is something that can't be done internally on a single worker. It has to take all the data off the workers, shuffle it around, change how that data is chunked up, put it back on those workers. Again, stuff we know, we've got actions that trigger that stuff. So we tend to see this kind of thing. So if I'm working with a particular set of transformations and I say, go run that action, go write my data or display my data, do something with my data, it'll then traverse back up that list of things I've asked that data frame to do, all the different transformations, the read activity, etc. And it'll work out a plan, it'll make a query plan. And that plan, anytime it's having to shuffle data, anytime it's having to change the number of RDD blocks my data is held in across the workers, this is a shuffle, called an exchange, in that it's having to take data off things, move it around, put it back onto other workers, and you'll see that represented. So you'll see I've got a number of tasks, then another number of tasks, and another number of tasks, representing different stages in my query. And there's a few bits of terminology in there. So we've got this whole thing is a job. So if I hit run on something saying data frame display or data frame.write, if I hit run on a action, that's going to trigger a Spark job or multiple Spark jobs depending on what I'm doing. And that's going to result in some kind of activity. Each time there's a shuffle, so a job is broken up into these things called stages. Each time there's a shuffle, it's a new stage with a new number of tasks, which represent the amount of blocks of data that need processing inside that particular stage. So if I'm saying, I want you to go and add up all of my data, there'll be an initial stage, which is reading the data in. Then another stage, which is each of the workers kind of doing its own addition, its own counts, if we say it's a count. Another stage, which is collecting the results of all those counts onto another worker to actually sort of collate the results. And then maybe another stage, which is sending the results, depending on where I'm putting that result. So each different element of the actual query that requires an exchange of data we'll see as a separate stage. Now, if we're using a load of libraries, especially like machine learning, data science type libraries, even with things like Delta, they might be doing some kind of pre-jobs, post-jobs, like reading transaction logs, updating states, all that kind of stuff. So sometimes it's a little messy in that you'll run something and you'll see several Spark jobs, but usually one of those is your actual query running. Okay, so we've got that idea. So we've got a cluster with workers, slots. We've got a job with stages and tasks. Again, as we're running a particular job, so when the first task go on, then it has to allocate slots. So a task fits neatly to a slot. So if I've got more slots available than I have tasks, then I can be running multiple jobs at once. So parallelism is managed by saying, well, what slots are free, what tasks are free, I've got 2 queries waiting to run. That one needs 200 slots. That one needs 8 slots. How do I fit them together so neither one is blocking too much? You get that kind of activity going on inside Databricks. And then again, as it moves to the next stage, all those take it up. As it moves to the next stage, it'll go across. That's the kind of activity we're going to see. And that having that kind of core thing in mind is really important for understanding what's going on in the Spark UI. Because that's how the Spark UI is structured. We've got tabs saying, what are my jobs? What are my stages? What's going on my executors? These are all elements of the Spark UI that essentially relate directly to this stuff. So let's switch over. Okay, this is actually from when I did the AQE demo, and there's deliberately some fairly gnarly queries in here. And there's a few different ways we can go and say, what's going on this particular cluster. So I'm going to leave that running. That's going to do a load of stuff. We can see there's some Spark jobs happening. You can see they have stages, they have tasks. So that says I have 8 tasks I want to run as part of this particular stage. So we're not going to break down. It's not having to do any shuffles, which is great. It's saying I've got one job. That job consists of one stage. That stage has 8 tasks. And I'm running on a fairly small cluster. I think I've got 8 slots. And you can see it's currently running 8 of 8. So that is how many tasks are currently running and how many tasks are there in total for this stage. So I'm running all of the tasks currently in parallel. So that's great, that's nice and efficient, and that's going off doing that. So we're going to leave that running for a second. And then in terms of how we get to the Spark UI, there's a few different paths. So we can we've got this button, that view button, which takes us to like a cut of the Spark UI for that particular job. It's like a little shortcut to go in there and work out what's happening for that job in isolation. So I can see this is the job, it's now succeeded, I can see that's going through, and I can see what was the actual thing I was trying to run, how long did it take, how many tasks were there, and how much data did I read as part of it. So you get kind of like that high level holistic stuff, and we can dig in and have a look at kind of more stuff that's going on. Again, my biggest thing, if you're looking at a query and trying to understand why it's taking so long, what it was doing, if you're trying to look at the execution plan and going, oh, that's fairly complex, I don't know what's going on in there, you've always got that associated SQL query, which is kind of showing you the Catalyst engine representation of what that was doing. And that little hyperlink, that kind of 80, is going to take us to just a super useful graphical representation. This is what's happening inside that particular query. So if you ever want to know what's going to go, so I can see it was taking a while because it's trying to get, it's generating 30 million rows as part of it. Project, basically a select is deciding what columns it wants, and then it's registering that in Hive. That's what it's doing. And you can go and understand why a query is working a certain way by taking that path. So under the particular job, if you expand that job, you can do view, you can see how many stages it is directly. If you want to know what's happening inside those stages, hit view, get that pane up, and then to really understand it, you've got the SQL query, or you can drill down into the later bits. That's one route of getting to the Spark UI. The other route, I can do the drop down here, so I can say, well, actually on this cluster, and I've got a link to the Spark UI there. So I can go directly to it, and that's not going to show me the Spark UI for a particular job. That's going to give me the general Spark UI for this whole cluster. And finally, I can get to the same page if I go to the clusters and I click on a certain cluster. I've got Spark UI as one of the options here as well. So there's a few different paths you can take to get to the Spark UI, depending on if you want to go straight to a particular job, or if you want to see what's going on in entirety on my cluster. And let's try that out, actually. Let's just, if we go and grab something, let's go just do a quick Delta thing. I'm just going to run that, attach it to my cluster. I'm going to have that running. I don't know if that demo is going to work, but we will see. There's a few things going. Okay, that one didn't work. Maybe we can run the other auto. I just run a few things, and then we'll have a few things going on the cluster that we can go and try and debug. We can go and see what's happening there. So, in my Spark UI, there's a few things that are general config. The event log is super useful. If you're trying to figure out what's going on a cluster, who started it, who closed it, when, at what point did they close it, and also, really usefully, if you've got auto-scale enabled on your cluster, you can see it in this event log. You'll see cluster resizing triggered by this. Cluster is idle, so I'm bringing it back down. The event log, super useful for keeping track of that stuff. It also gets a load of error type things. So if you're seeing any weird responses because it can't spin up a node, it can't get hold of the driver, all that kind of stuff, you'll get those appearing in the event log. Hopefully, that's really rare. So most of the other stuff we're seeing in the Spark UI. So Spark UI is where we're seeing things. So as a super high level thing, you've got jobs. That is, what are the individual whole chunks of work I've given to the Spark driver. Not just me, anyone using that cluster. It's kind of like the execution log of things going in. There's a few different things in there. Stages, so those jobs break into those multiple stages depending on how many exchanges within that particular query. And that's kind of that lower grain. So essentially, stages are these child objects of jobs where we get a better idea of number of tasks, how the task was spread across workers, that kind of stuff. Storage is for caching. So if I've got a particular data frame and I've said data frame.cache or data frame.persist and chosen an in-memory option, then it will store that data in memory across my workers. And if I'm curious going, ooh, maybe they were skewed, maybe actually the blocks of data that my data was in is actually massively skewed. So one worker's got loads of stuff in memory and the cache is eaten up, the other one's fairly empty, and I'm trying to troubleshoot how that's going on. Or even if I'm just deciding whether it's worth me caching data and I want to check what's already cached. If I try and cache a big data set, am I going to knock existing things out of the cache? And you can see that in the storage layer. So storage is annoying because storage makes you think that's physical storage. That's about files on disk. It's not. Storage is all about memory caching. So we can go into what's in memory across my various different workers. Environment, that's more environment config, so the state of things, environment variables, what version of Spark you're on, all of that kind of stuff. Executors, that's what are all my different executors. So in this case, I've got 2 nodes in my cluster, so I'll see 2 node records for my different workers and then 1 node record for my driver. I can go and say, well, how busy are they? Oh, that worker's working overload. That's got tons and tons of tasks waiting. The other one's idle. I've got skew. I've got something going on. And I can go and dig into it. SQL, as we saw, that's when we get that kind of graphical thing. That's essentially kind of the output of the Catalyst engine. It's how it's interpreted the query and the query plans it's using. ODBC, JDBC, that's if people are poking that endpoint. So if I've got things like Power BI or Tableau, and they're using Databricks as a essentially data source, and they're throwing queries in, I can get some information about what's going on there. And finally, got the new structured streaming UI. So if I'm doing some cool streaming type stuff, I can go in there and see what's happening. That's really new, collects loads of really useful info, super useful. But let's do a more detailed dive. So I'm in jobs. I can see a few things. So I can see there's one job currently running. So I can see something is running. How big is it? It's got 4 stages. Okay, it's got quite a few tasks. Only one of my stages running. Okay, maybe does that make sense? Why is that taking so long? So I can dig into that and say what's going on. So we'll do that in a second. I also get completed jobs. See failed jobs. I think if I can have that up. Failed jobs. So you can kind of just have a big, really quick, high-level overview. What's currently running? What succeeded? What failed? So if someone's saying, "Oh, I had an error on the on Databricks. Can you come and help me out?" You can hop onto that cluster as long as it's still turned on. Go to failed jobs and get there and go, okay, so something failed. What was happening? Oh, okay, so some of the tasks failed. And then you can drill down on it. You can go and see it, and you can get the errors and all that kind of stuff. Go and just say what happened on this particular thing. Get the failure reason. Okay, there's a problem. Like, okay, I had a Java character. Again, that's just a weird thing I tried to run. Get lots of info from there. So debugging failures and drilling down to user activity normally do through that kind of thing. If we go into our one that's currently running, I'm like, well, why is that taking so long? That's been going for a little while. Why is it taking so long to do that thing? I can drill down on this description. So this will give me kind of a job page, which gives me more detail for that jobs. So I'm still in the jobs tab here. I'm just kind of inside a particular job. And again, that's where I can go and have a look at that SQL query to find out what's going on. I can see how many stages there are. So I can see it's currently in the middle of running 1 stage. There's another stage that's yet to run, and it's completed 2 stages already. So I can say, kind of, if I've got that query plan, and I know there's a small reading stage, a bigger transformation stage, and then something where I'm doing something fairly hairy, and then another stage, I can kind of go, right, what stage is it at? Okay, so it's trying to actually collect the results. So it's trying to do one of the steps of my thing. So what's actually going on in there? Okay, to display my skewed data frame. I can tell you there's some details in there. I've got something deliberately skewed. It's taking a while. So you can go and see and kind of get a bit of a thing. There isn't that much useful stuff in there unless you really like going down the deep levels. But why is that one task that's still remaining? And that feels a bit weird. So normally you kind of see it kind of chunking through. It's just working through the task at a regular level. I can see at this point there's one running task. It's gotten through 199 of them. Been going for 4 minutes. That seems a little weird. And we can drill into the details for that particular stage. So got a stage here. This is my stage ID. Drilling into this one will take me into the stages tab. So I'm then having a look for a particular stage, what is going on that stage. So total time across all tasks, let's see what's going on. Reading a fair amount of data. So you get some high level, what is actually going on for this stage. You can go to the parent view. I've got some different views about what's going on to get that kind of what's going on here. So I can see it is actually doing shuffles. So this is the RDD visualization, which can be a little bit harder to read than the SQL one that's associated to the whole job. But you've got the SQL one for the job as a whole. You've got the DAG, in this case, for this particular stage. And it depends on the level that you're trying to understand stuff. I get some general high-level stats. And then I can see, for those 200 tasks, so we knew I was on number 199 out of 200. It'd say what's going on all of my different tasks. And I can get this list. So I've got all these different succeeded tasks and say, how big were you? So most of them took 3 seconds, 3 seconds, 3 seconds, 2 seconds, all nice and quick. And then there's one, okay, so most of them are reading 12 meg of data. Most of them are really, really small. And then there's a beast. There's one block of data. One of my 200 chunks of data is actually 5.8 gigs so far that it's read. So I've got massive skew that just one particular task is way, way bigger than the others. So I know I need to look into that and try and figure out how do I resolve that skew. So you've got that whole idea, this whole thing in the Spark UI of going from jobs top level, what are all the things that are happening? Job detail, what's going on in this particular job, what are the stages, how long has it taken, how much data am I reading? Down into the particular stage with some high level stats about that stage, right down to the task level. So in this stage, I had 200 tasks, 10 tasks, whatever it happens to be. How big was each task? Where's the skew? Where's the bottleneck? So I can see there is a problem here, and I can then do a bit of profiling. I can then say, well, actually, just show me how many records. Am I doing a repartition on a certain column that's causing this skew? In which case, I can change how I'm doing it. So that whole idea of kind of this drilling down and down and down in terms of the depth of the levels is kind of really interesting to understand what's going on in Spark UI. So super useful. First query debugging, jobs, job details, stages. Now storage, two things we use storage for. As I said, there's caching. I've not cached anything currently. If we did, we'd see an RDD here with basically a query plan. Because when you cache something, it's not like, so if you had SQL Server and you said, just store this as a global temp table and it's cached, then if someone refers to something with that name, it'll go and get it back. That's not how caching works in Spark. Caching works based on essentially the execution plan. So if someone else writes the exact same query, writes a data frame against the same location with the same transformations and all of that kind of stuff, it'll actually reuse that cached version. So caching persists across the cluster. When you restart the cluster, it'll disappear. If someone tries to fill the cache, it'll drop out the one that was accessed the longest to go. So kind of first in, first out style. No, last accessed, first out style caching. So it's not always going to be there. But if you do cache something and then someone else runs the same thing in a different notebook in a different Spark session, but on the same cluster, it will reuse that in-memory cached one. So you need to be a little bit careful to make sure you're not accidentally doing that if you don't want to. And then it has this thing, the delta table state. So I've accessed a delta table, and Spark has gone off, it's read the transaction log, and then it's just cached that transaction log. So rather than every time when I access that table, it has to read the trans log, work out what to do, and then run the query, if it just persists this in cache, because it's tiny. It's got kind of, a number of bytes or kilobytes. They've got a tiny amount of data in here, just to save that little bit of lake access, just to speed that up a little. And also there's, when we've got checkpointing and all the kind of new stuff that's coming in to speed up the delta state access, that's again going to be improved in terms of how long that takes. So storage, all about caching. You can see how much data I've currently got cached. So you can see, not that much. I'm not using that much. If I had a big one here, I'd see how many partitions. And you can drill down, again, this won't tell us too much on a delta state object. I can see there's just one RDD block. I can see how big it is. And I get an idea of which executor it's on. So my horrendously skewed data frame, if I cached that, I'd see 200 RDD blocks. And I'd see one of those RDD blocks, which is that massive 6 gig one, is on a particular worker. So actually, the cache for one of my workers would be way, way, way more utilized than another worker. And again, you can see that kind of thing coming into storage, looking at the various things that are cached, and drilling down onto the one that's a problem. The other way of seeing that is via executors. So we just switch over to the executor one, we'll go back to environment. We can see what's going on my cluster. So currently got 3 active nodes. Again, 1 driver, 2 workers. So your driver always appears as one of those active particular people. How much storage memory do I have across my various workers? So I'm using 20 meg for the Delta cache. So I can see I've got 10 gig free of available cache that I'm not using. So again, if you're looking at this cluster and people have been caching stuff, you can go on there and say, how used is it? Is it free? Should I start caching stuff because I've got a load of memory sitting there not being used? Or actually, oh no, we've got a load of stuff that's reserved in memory cache and I don't want to kick that out. You can get that idea. If something's going really, really slowly, it could be because it's trying to get it into cache and having to put something out and then put a bit in and then put something out and put a bit in. And that could be a reason for why something's going slow, because your storage memory is full on that particular workers. Maybe you need to pick a VM size for your worker with more memory to CPU, or have more workers and spread the work out. Again, you can see total utilization there. So I can see I've had some failures, I've got some active ones. On my individual executors, I can see what's going on. Okay, so actually, my cluster is currently fully utilized. Both workers currently have 4 active tasks, meaning all 4 slots on both workers are currently full. So if someone else wanted to run a query and it was sitting there waiting, going, can't run yet, waiting for space on the cluster, it's because the cluster is currently in use. So if you're using a cluster for concurrent executions, and you're wondering, why is it taking so long? You can go in here and go, oh, something's currently running. My cluster's full. And then how do we find out what's running? We go back to jobs and we can go, what's using up those 8 tasks? Okay, there's an active job. Oh, and that's still my skewed one, but it's gotten past the other bits, so it's still actually eating up stuff. So you can use executors to work out kind of holistically how busy is my cluster, and then jobs to say what's actually running on it. So again, all these different panes give you a different viewpoint to what's going on the whole cluster. And again, this is cluster specific. Okay, so loads of stuff we can do, loads of stuff we can understand. SQL, again, this is kind of showing us that kind of user execution, just a different way of seeing what's going on. Anything that's gone through the SQL engine we'll see here. And we can drill down. So it's related to a job. So we can see this is still the same job. I can go back to that job pane, or I can click into it and say, what are you actually doing in here? And I get this kind of the SQL query style plan. So we saw for that stage, we had the DAG that's just specifically in that stage that was kind of explaining this exchange. So what we're saying earlier when we said that each exchange denotes a different stage, in this one, because this is the whole job, we can see what those exchanges are. We can see when it's doing a shuffle. So I can say, well, like, okay, this is doing some work, so it's scanning Parquet, bringing it in, it's doing some filtering, and it's projecting it. But it's doing that on 2 different bits of Parquet. So essentially, I'm doing read that file as one stage, read that set of files as one stage. Then I'm having to do an exchange. I'm having to put those down, chop them up, put them back on the workers in a different state. Then having to do a sort merge join. That can perform quite badly, but you know I can troubleshoot that. I can understand that kind of makes sense why there's a problem with skew in there. And then I'm doing an aggregate. So then each worker is getting the results of that aggregate and then sending the results together so I can collate them, which is why there's another exchange. And again, it's this nice view. So if you're trying to understand what's going on in a given stage, you can use in jobs, drill down to that stage, look at the DAG to understand what it's actually doing in fine detail. You're trying to work out just why have I got 4 stages? Why is it doing so many shuffles? All that kind of, why is it doing what it's doing? That kind of SQL view gives you the overall query plan for what's going on. I mean, you could get the same thing by just doing dataframe.explain and you get the text version, but this is kind of nicer to see, and you get the things it's already done. If it's gathered some stats while it's doing it, you can actually work through it. So you get the results as it's going through, so you can understand what's going on inside this query. So SQL super useful. I don't have the JDBC running at the time. This gives you session information. So essentially, it's kind of like if I don't know about a user because it's kind of coming in externally, I can see some stuff. I can see anything it's doing with SQL. I can see any stats it's gathering. I'm expecting this to get a lot better with some of the Redash stuff as well. So when we're kind of starting to see Databricks with its own kind of dashboarding engine, all that kind of stuff, we're going to see some cool stuff hopefully coming in there. And streaming, I don't think I've got anything streaming currently. No. I'm going to do a separate session on the structured streaming UI because it is quite new and it's got a load of cool stuff in there. So we'll have a look at streaming and we'll have a look at some of the different things we can do in another session. So that's the basic Spark UI. That is basic. There's a lot in there. There's a huge amount of info to get started on Spark UI, but lots of things for different scenarios. There is a historical cut. So if I've shut down my cluster, I can go in here and kind of get an idea of what happened historically. Don't know if any of these will still have their history, but we can try. There we go. So it actually goes off, it queries the old log files, and then it'll give me a view of what's happened. So I can actually say, okay, no, I don't have much actually running on here I can go and do. If you've been running on it fairly recently, you can go and dig into your history and then get an idea of kind of these things. So even if you happen to have shut your cluster down, you can get some of the logs. It's not as fine-grained detail. You don't get right down into the depths. It's not useful for querying what's happening currently because your cluster's turned off, but there's definitely some useful stuff in there. Now, finally, look at metrics. Now, metrics are super useful, and we keep getting that question of someone going, how do I know if my cluster's being utilized? How do I know if I should have a bigger cluster? I've turned a cluster on and I'm using it a lot, but are we actually using it? Or should I actually turn it right down? Can I have a slither of that cluster open? And that's exactly what Gangly is for. So you get a load of kind of historical metrics files, and you can dig in, and you get this kind of like PDF of this is what's going on my particular server. So you get cluster load, you get memory usage, you get CPU. And yes, it doesn't look that pretty, but you get actually a lot of information about how your cluster is being utilized. So if you're looking at a cluster that's been turned on and it's had a whole day's worth of activity, you can just go into your metrics on a particular cluster and you've got these hourly or 15-minutely snapshots giving you that viewpoint throughout the day of how busy it is. So if you get a load of service requests and you're looking at kind of when do people complain? Everyone complains about lunch. Why are people complaining at lunch? You can go and have a look at the metrics and then say, oh, suddenly, everyone on their lunch break was just having a play and testing out the new functionality, and suddenly they've battered the cluster. And you can see that by going into the historical snapshots. You have the live Gangly UI as well. Opens up a different dashboard. This is much more interactive. You can go and drill into what's going on, go and see different things. You can go and change the different things. So I'm looking at an hour currently. Got 2 hours, depending on how long my cluster is. It's only been turned on for 2 hours. You can go and explore this to get a huge, absolutely gargantuan amount of data about your cluster running telemetry. So if you want to know how your cluster is being used, whether or not your executors are completely skewed, whether people are hammering it during the day, you've got a lot in here. So this is just your main view, has a ton of stuff. You can specify one of your given workers if you think there's a worker that is having particular issues. And there's a whole lot of extra stuff that is built in. Not all of them work. We get a few odd things in Databricks, but certainly that kind of initial snapshot of what's going on my cluster, this is so incredibly useful. So if you're not currently using Gangly, if you don't use Gangly at all, you didn't even know it was there, it is a little bit hidden away. So on your cluster, go to metrics, go to the Gangly UI, and then you can see that telemetry. Now, some of that telemetry gets kicked out to log analytics. You can get some of that after the fact. But certainly, if you want to tweak or play with the size of your cluster, what's going on, all of that kind of stuff, look at Gangly UI. Go and have a play, get some of the stats. Try and run a few jobs during the day, go back afterwards and see if you can find out where those performance bottlenecks are, why they were happening, what's going on there. And then that is just a super, super, super useful thing to be aware of. I'm kind of sad I left that to the end of the video. So, if you made it to the end, well done. You've got Gangly, you can go and have a look at it. If the other guys didn't, they're just going to have, poorly performing clusters. Sucks to be them. Alrighty. So hopefully that was useful. I know there's a huge amount of info there. The whole thing is getting used to that little hierarchy of going, what's going on my jobs? What are my job details? How many stages did I have? What's going on in each stage? What's going on at the tasks? If you understand that hierarchy of how Spark is breaking up work, how Spark thinks about taking data, turning it into a number of RDD blocks, which translate immediately to tasks. So if I read a load of data, that's 20 tasks. That relates to 20 slots. I need 20 little bits of CPU in order to process that data. If you've got that right in your head, and then other people are running things and going, why is it only doing 2 tasks at once? I've got an 8-node cluster. You can go, well, someone else is running a query and they're using 6 of the slots. Getting that idea of you have a number of CPUs, how many CPUs is each thing working, that is how concurrency works. That is how you manage different things. That is how the Databricks job scheduler just fits, kind of neatly maps different people running queries to each other. So it kind of jigsaws queries together. So it can be running things at the same time just by using a variable number of slots. So super useful. Spark UI, loads of stuff in there. By far the easiest way to start working with it is to have a go. Just get in there, try and debug some stuff, leave a long running query going, go and have a look and see if you can find out what that's doing. Um, and yeah, let us know how you get on. If you've got any questions about it, anything that you wish was in there, anything you don't know where to find, then drop us a note in the comments and we'll see what we can do to help. And otherwise, yeah, don't forget to like and subscribe, and we'll see you in a future video. Cheers.